Let's use this model to show how the James Webb works and some of the important parts of it. So light from a star or a galaxy would shine down onto the main mirror here, this set of 18 individual mirrors. Those focus onto the secondary mirror at the end of this tripod, which then reflects the light down the tube light baffle into the science instruments, which are in this black box behind the main mirrors. Everything is kept nice and cold by the large sun shield, which on the real observatory is about the size of a tennis court and is made up of 5 very thin layers of plastic. So each of these Lego tiles is actually much thicker than the real layer on the real observatory. Why do we want to study the universe in the infrared? 2 primary reasons. The light from early galaxies in the universe that are billions of light years away travel to us, and the universe is expanding. As the light travels, it gets stretched to longer wavelengths. So what starts out in the optical, visible or ultraviolet regions of the spectrum gets stretched out into the infrared.
With infrared, you're looking at heat energy. So for James Webb, the best way of doing that, of turning out all the other lights, is to make it as cold as possible. So James Webb gets cooled down to about 40 degrees above absolute zero. And it achieves that by having this giant sun shield. Basically blocks out light from and energy and heat from things like the sun or other planets or anything else generating heat. The instruments themselves also have to not generate heat. Everything has to get cold. And then that allows you to then start observing the universe with minimal noise and pick out those tiny signals of light which are, so far away.
The infrared is good for seeing through clouds of gas and dust, which are often present where stars and galaxies are forming. So we can cut through that gas and dust to see stars forming inside what we call stellar nurseries.